Namaskar. We are aware about the del operator, which is the vector derivative operator given by I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. Also, we are aware about the scalar function. In previous video, we have observed the scalar function is denoted by a small letter. Let f be the scalar function. One example of scalar function is 3x square y minus, say for example, 2z cube. Correct? Such function is known as scalar function. And we are aware about a vector function, which is, say for example, a bar is equal to it is x y square I cap minus 2y cube j cap plus x y z k cap. In previous video, we have observed what is the meaning of scalar function and what is the meaning of vector function. Now, in case of the scalar function, just we can say that it is f of x y z in Cartesian coordinate, and in case of a vector function, we can denote it as ax I cap plus ay j cap plus az k cap. Now we will have to note that ax is the function of xyz. It is the x component of the function, vector function. Here we will observe that this is our x. It is not necessary that it depends only on x. This is our ay, which depends on y. In this case, it depends only on y. But it is not necessary that the ay, that is the y component of vector function, will depend only on y. It is not necessary. And similarly, this is our az, z component of the vector function. Okay. Now, in this video, we will discuss the operation of del operator on the scalar function and operation of del operator on the vector function. Now, as we know, the del operator is the vector derivative operator, and it is a vector quantity. It is I cap, j cap and k cap, and therefore when we operate this operator on the scalar function, I will have to write it is del f. It is referred as, or it is known as, gradient of the function f. It is gradient of f. Later we will discuss what is the physical significance of the gradient. When we operate the del operator on the vector function a bar, now both are vector, and therefore there are two possibilities. Either we can think about a dot product, or we can think about a cross product. That means either there is del dot a bar or there is del cross a bar. Now, del dot a bar is known as divergence of a bar, and del cross a bar is known as curl of a bar. Now, it is very simple actually. See, when we think about the del operator operated on a function, we will begin. What I will have to do? I will have to write the del operator. Therefore, I can write it is I cross I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. And what I will have to do? I will have to operate this on the operator. Let it be f, which is the function of x, y, z. Correct? I will have to operate this. Then what I will have to do? Using the property of distribution, I will have to operate this I cap dou by dou x on the function. Similarly, j cap dou by dou y on the function, and k cap dou by dou z on the function. And I can write it is I cap dou by dou x of f. Now, it is not necessary to write every time it is x, y, z. F is the function of x, y, z. Plus, I can write j cap dou by dou y of f plus k cap dou by dou z of f. This is function. And this is the gradient of f, that is grad f. Now, similarly, when we will have to operate this del operator on the vector function a bar, that is, if I will have to calculate the divergence of a bar, what I will have to do? I can write it is I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. It is the del operator, and then dot But now in general I can write a bar is equal to ax into I cap plus ay into j cap plus az into k cap. It has three components, and we know that if I operate this operator on this, it is similar to the product of a bar and b bar. Here if I operate, you see again, if I use the property of distribution, then I will have to do I cap dou by dou x on ax I cap with a dot product. Therefore I cap dot I cap is equal to 1, and simply I will have to write dou by dou x of ax plus, if I will have to operate this I cap dou by dou x on ay j cap, then it will be dou by dou x of ay. It may not be 0 because here we have observed that ay may depend on xyz. In this case it is not, but az depends on xyz. But if we think about the dot product of I cap and j cap, that is I dot j, it is equal to 0, and therefore though dou by dou x of ay may not be 0, I cap dot j cap is equal to 0, and therefore this term will vanish. Similarly, if we operate I cap dou by dou x on az k cap, then derivative of az with respect to x may not be 0, but I cap dot k cap is equal to 0, and therefore this third term will vanish. Now we will have to begin with the operation of j cap dou by dou I on ax I cap. Again the same situation, dou by dou I of ax may not be 0, but j cap dot I cap is 0. They are perpendicular to each other. J cap dou by dou I on ay, we may not be 0, and similarly j cap dot j cap is definitely non-zero, it is 1, and therefore this term remains as it is. It is dou by dou I of ay. And now if you think about the operation of this j cap dou by dou I on az k cap dou by dou z on ax I cap, k cap dou by dou z on ay j cap, you will realize that these terms are 0, but k cap dou by dou z, if we operate on az k cap, then k cap dot k cap is equal to 1, and I will have to write it is dou by dou z of az. Means if I will have to calculate the divergence of a bar, then that is nothing but the partial derivative of x component of the vector function with respect to x plus the partial derivative of y component of the function with respect to y plus the partial derivative of z component of the function with respect to z. And this is the divergence of a bar, that is del dot a bar. Now exactly in the similar manner we will proceed further for the calculation of curl of a bar. Therefore here we will write it is del cross a bar. Del cross a bar is the curl of vector function. And how can I write this? Again it is I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. This is the del operator, and cross I will have to write it is ax I cap plus ay j cap plus az k cap. Now there are two ways. Either I can operate this operator I cap dou by dou x on ax I cap, then ay j cap, and then az k cap. Similarly for j cap dou by dou y and k cap dou by dou z on these three components. And I can write this, correct? I will write this, and then I will show you what is the another way of finding the del operator, finding the curl of a bar. Okay. See, I cap dou by dou x, if I operate on ax I cap, then I cap cross I cap, this is cross product, correct? I cap cross I cap, and interesting thing is that I cap cross I cap is equal to 0. In case of a dot product, I cap dot I cap will be 1, but in case of cross product, I cap cross I cap is 0, and therefore this term will vanish. But if I think about dou by dou x I cap operated on ay j cap, then I will have to write it is dou by dou x operated on ay and I cap cross j cap, and we know that I cap cross j cap is equal to k cap. It is in right-handed Cartesian coordinate system. Therefore this term will be a vector term. If I think about I cap dou by dou x operated on az k cap with a cross, then I can write it is plus. I will not write the sign first because you will realize later on. I will have to write it is dou by dou x of az and I cap dot k cap. But what is I cap dot k cap? It is right-handed cyclic coordinate system. Therefore, I cross j is equal to k, j cross k is equal to I, k cross I is equal to j. But if I think about reverse way, k cross j is equal to I, j cross I is equal to k, and I cross k is equal to j, and all these with negative sign, and therefore k cross j is equal to minus I, j cross I is equal to minus k, and I cross k is equal to minus j. Therefore here I will have to write it is minus j cap plus, or I will not write the sign first. Dou by dou I operated on x, therefore I will have to write it is dou by dou I on of x and j cross I, and just we have observed that j cross I is equal to minus k, therefore it is k cap with negative sign. Dou by dou I of ay, it may not be 0, but j cap cross j cap is definitely 0, and we will have to ignore that term. And the next term will be dou by dou I of az, it is dou by dou I of az, and j cross k, and j cross k is equal to plus I cap. Therefore I can write this like this. Then the next term will be, we will have to operate I cap dou by dou z on these three. Therefore I will write it is dou by dou z of ax if I operate this on first x component of a bar, and k cap cross I cap is equal to j cap, correct? Ki, they are cyclic, ki, j, and therefore it is with plus sign. If I operate this dou by dou z on ay, I will have to write it is dou by dou z of ay, and k cap cross j cap, it is in reverse way, therefore k cap cross j cap is equal to minus I cap, and the last term will be 0 because it is k cap cross k cap, and that is equal to 0, therefore no need to calculate dou by dou z of az, and this will be the term, it is curl of a bar, correct? But if we observe this equation, then this equation can be arranged in the form of a determinant, correct? Therefore I can write it something like this, like the cross product of a bar and b bar. Here I will have to write I cap, j cap, and k cap. The coefficients of first, that is first term or first vector, that is del vector, it is dou by dou x, dou by dou I, and dou by dou z. These are the coefficients of I cap, j cap, k cap in case of first vector. Cross, this is the second vector, I will have to write the coefficients, and therefore here I will write it is ax, ay, and az, and this is nothing but del cross a bar. Now as a homework you can check, because we are aware about how to simplify this determinant. I will have to hide the first column and the row, therefore this is common, and therefore coefficient of I cap is dou by dou I of az into I cap minus dou by dou z of ay. Here you can search for the coefficients of I cap. See, it is dou by dou I of az with I cap and dou by dou z of ay with negative sign I cap. See, it is minus dou by dou z of ay, and you can check that these three terms, or these 1, 2, 3, 4, 5, 6 terms can be derived from the simplification of this determinant. And this is about the operation of the del operator on scalar function, which will give us the gradient of a scalar function, gradient f. If we operate the del operator on a vector function, there are two ways. If I operate with a dot product, then it is the divergence of a bar, divergence of a vector function. And if I operate the del operator with the cross product, then it is curl of a bar, that is curl of a vector function, it is curl of a bar. In the next video with some example, Let the same example, we will assume this f to be the 3x square y minus 2x z cube and a bar is equal to this. We will try to find the gradient of this vector scalar function, the curl of this vector function, curl of this vector function and divergence of this vector function.